All right. Hello, everyone. So I'm Shan Ghosh, and we also have Pulkit here, Pulkit Mangal. So we are the TAs for this Introduction to Competitive Programming course. So today's session will be a programming assignment discussion session. So it's not a doubt clearing session. So I'm sure you'll also have scheduled sometime in the future. So I have a sir who will be taking those sessions. So he's currently not in the session today. So we'll start off with week one and week two. So I'll take the first questions and Pulkit will take the second questions. We'll just explain the question at first. And if you have any doubts, just unmute and let us know. We'll also clarify your doubts regarding those questions. So I'm going to share my screen. One second. Yeah, let me know if my screen is visible. Pulkit, my screen is visible, right?
Yes, yes, sir.
Yeah. Okay. All right. So this is the so ignore the this. So this is actually week one. Week five, week one, programming assignment one. So the first question states that Rahul is looking for some special numbers, and the numbers he is looking for should satisfy a specific constraint. So the number, when prime factorized, should contain all prime factors of the same parity. So what does this mean? So this means when we prime factorize a number, prime factorization is breaking down a number into all of its factors which are prime. So if let's say a number has a factor of 16, that is not prime. So we break that down further. So we can break down 16 into 4, and then we can break that down into 2 into 2 into 2 into 2. Right? So that is basically prime factorization. So what this says is all the prime factors of that number should have the same parity. Now, what is parity? Parity basically describes whether a number is even or odd. So if a number is, if one of the factor is even, all of the factors should be even. And if one of the factor is odd, all of the factors should be odd. After that, we are also told that the number itself should be an even number. So this is one hint which we have to, which will basically help us to check whether the number is this special kind of number or not. Right. So the first we'll also discuss how the input works, especially now because this is the first session, and some of you might not be used to working with programming test cases, with like programming questions with multiple test cases. So the input, along with the input for the question, will also have a integer called t, which is the number of test cases. So the first line of almost most questions will have t, which is the number of test cases. This means that in that one input, we will ask the same question t times. So you have to actually loop t times and take t inputs for each of the test cases. And then for each test case, it contains a single integer n, which is the number we have to check for this question. Right. So we are also given a few constraints. So this basically tells that the input which is given will always lie in between these range. So the t will never be more than 10 to the 5 and the n will never be more than 2 to the 60. Right. So let's just see an example here. So if the number is the special kind of number, we should print yes, otherwise no. So if the number is 262623, then the answer is no. This is because 262623 can be prime factorized as 3 times 87541. And here, both the factors are of the same parity. That is, both are odd. So 3 is also odd and 87541 is also odd. But the number itself is odd. So as mentioned in the question, the number should be an even number. So that condition is not satisfied. So the first output is no. In the second question, 124, here the number is even. However, the prime factors 2, 2, and 31. Here 2 is even, 2 is even, but 31 is not even. Right? So this is odd. So that is why this is also not satisfying the constraint. And so the output is no. Finally, for the third one, 131072, this satisfies both the constraints. So the prime factorization of this, one second. So yeah. So if you do factor of 131072, you see that it is basically a lot of twos, right? So it's a power of two. And that is why, so because the number itself is even and also all the prime factors are even, that's why this will satisfy. Now, that is basically the trick to this question. So if you actually pause and think about it, if all the factors have to be either all of them have to be even or all of them have to be odd, and the number also has to be even. So if the Ayush, if you don't have any doubts, you can mute now. If you have a doubt, you can just unmute and ask. Yeah. So yeah. So if the number has to be even, then there needs to be at least one two present in the prime factor. But if there is a two present, which is even, then all of the other prime factors have to be even. Now, there is only one even prime number, which is 2, and there is no other even prime number. So that means that the number has to basically be a power of 2, or the prime factor should exclusively contain 2. So that is the trick to this question. So once you understand that, or once you decode that, then the question is pretty simple. You have to just see if the number is a power of 2 or not. Now, there are multiple ways of doing that. One way is you can just keep on dividing the number and see if you get a remainder or not, dividing by 2. But there's also a simpler solution than that, because we are using the binary notation, because we are storing the number in the computer system in memory. So the number itself is stored in binary. So in binary, if a number is a power of 2, it will be one bit will be on, and then all other bits will be turned off. So for example, if the number is 32, we'll have 1 followed by 5 zeros. One second. Just give me 1 minute. Let me connect my pen tab. In the meantime, you can pause and think about why this is true. So if a number is the power of 2, why will its binary representation contain only one, and then all of the following bits will be 0? Yeah, am I audible now?
Yes, sir.
Hello? Yeah. Okay. So as I was saying, so if we have a number, let's say 32, so 32, which is in base 10, if we represent it in binary, it will be 1 followed by zeros. So 1, 8, 16. So this is how some of is uh, familiar with and quickly look critically how if yeah. So if it is not a power of 0, then it will be a combination of ones and zeros. However, if it's a power of 0, so if it's 2 to the n, then it will have 1 at the nth position, and then all of the others will be 0. And similarly, if we take the number just before it, if we take 2 to the n minus 1, so this will be ones in all the positions and 0 at the nth position. So all the other positions, it will be 1. So this is simply how binary addition works. So this case where this bit is flipped and all the other bits are flipped only happens in when we go from 2 to the n minus 1 to 2 to the n for any n. So we can simply check for this. So if we take the number that is given, which is n, so the number that is given, if this if we AND it with n minus 1, so the number before it. So AND is a bitwise AND operator. In bitwise AND operator, we basically check if both the bits are true. So here 1 and 0. So one, this is 1 and this is 0. So both are not true. Similarly, this is 0 and this is 1. So both are not true. So this like none of them will both be ones. So if none of them are 1, then this means that n is a power of 2. So this is basically what we have checked here. If n is greater than 0 and n minus 1 equals 0. So then we print yes, then it means that it's a power of 2. So this is one quick way of checking if a number is power of 2. And this will actually not take any iteration. So this can be done in O of 1. So this is the hello. Yeah, Ananta, you can mute yourself. Yeah. Yeah. So this will basically run efficiently in O of 1 time. And another thing you have to note if you are using any other language other than Python is the question asks that the number itself can be in range of 2 to the 60. So in that case, you actually need to store the number as a long. As you can see, the number n has to be stored as a long. If you don't use long, your code might work for some test cases, but some test cases where we are actually giving a long number, it will not work. So in Python, you don't really have to worry, but in C, C++, and Java, make sure that you're using a long for this. Right? And the logic remains the same. You just AND between n and n minus 1. And if the AND gives you 0, then it's a power of 2. So then you print yes, otherwise you print no. Right? So is there any doubts for this question? Okay, so if not, then we'll move on to the question 2. So Pulkit, can you continue with week 1, problem 2?
Yes, sure, sir. Okay, is my screen visible?
Yes, it's visible.
Okay, so the problem 2 for the week 1 assignment is that he shown a special locker to securely store his important letters. Now, this locker has an advanced password mechanism. The password is determined based on the numbers of letters stored inside the locker. If there are n letters, then the password is the digital root of n. And our task is to write a program that calculates the password for the locker given the number of letters n. And as it is mentioned that the password is the digital root. So what is digital root? Digital root, which is also known as a repeated digit sum of a number, is the single digit value obtained by iteratively summing the digit of the number until a single digit is achieved. So for example, if you are taking the 1 to 3 as your digit, then if you sum the each digit in this number, that is 1 plus 2 plus 3, you will get 6. So 6 is the digital root for the 1 to 3. Now, if we take another example, let's say 5432, then you when you sum these each digit of this number, 5 plus 4 plus 3 plus 2, so 5 plus 4 9 plus 3 12 to 14, you will get the number 14. But it is still not a single digit number, so you have to again sum this, that is 1 plus 4 equal to 5. So 5 will be the digital root for the number 5432. So you have to basically calculate the digital root for the given number, and that is basically the repeated digit sum until you get a single digit number. So there are some input format that is given to you, that the first line of the input contains a single integer t, which basically represents the number of test cases that will be there. So as Cyan explained it before, the first line would be the number of test cases. So you have to loop through it, and for each test case, there will be a single line input which contains a single positive integer n, which represents the number of letters in the locker. And this is the integer for which we have to calculate the digital root. And the constant that is given to you is the number of test cases would be less than equal to 10 power 5, and n is a positive integer, and n can be very large up to 10 to the power 15. And the output format would be a single digit integer, which is the digital root of the n. So we have given this sample input for the example. The first line, it contains the number of test cases. So there will be two test cases. The first test case is 123, and the second one is 9876. So if you calculate the digital root of 123, it is 1 plus 2 plus 3, so 6. So 6 will be the answer for the first test case. For the second one, if you sum these digits, that is 9 plus 8 plus 7 plus 6, so 9 8 17, then 24, then 30. So you'll get 30, but 30 is still not a single digit number. So you have to again sum it, that is 3 plus 0, so 3. So 3 will be the answer for the second test case. That's the same explanation that is given here. Now, if we move on to the solution code, one basic solution that one can write is we can loop through it. That for the given number of test case, you have to loop through the number of test cases, and then you have to take the input n. Now, the solution that is given here, let me switch to okay. So the solution that is given here is with respect to one solution that is available on the Wikipedia page, that we can get it from here. So there's one analytical solution to finding the digital root for any number, that using this formula. So if we want to find the digital root for any number which has a base b greater than 1, then in the base b format it would be, if n is 0, then the digital root for that number would be 0. If n is not equal to 0 and the mode of b minus 1 is equal to 0, then it would be b minus 1. And if it is not equal to 0, then it would be n mod b minus 1. So this is the analytical formula that we are using to calculate the digital root for the number. And using Python, we can write it as here. So if we take the number as input, if n is 0, we will just simply print the 0. If it is not 0, then we will calculate its mode. And as it is given, we have to calculate it with base b minus 1. So that is 9 here. And we will print mode if the mode is not equal to 0. Otherwise, we will just print 9. That is b minus 1 with base 10. The same type of solution is given with the other language also. So anybody has any doubt? Okay. And maybe we can start with week 2. And you can start with week 2
Yes.
programming assignment.
Yes, sure. One second. Let me just share my screen. Yeah, hopefully the screen is visible for week 2 assignment. So this is the week 2 programming assignment 1. So in this question, let me zoom in. So in this question, you are the sports teacher of a school and there are n students in your class. You ask the students to stand in a line according to their heights, and they run laps throughout the circular ground. Right? So basically, what this means is you have students who are standing according to their height. Right? So, for example, if let's say there are some students and these are their heights, so they will be standing according to their heights. So the taller ones on one side and the shorter ones on one side. So this was their initial ordering, but then they are then running arbitrary number of laps around a circular ground. So if someone is running in a circular ground, you don't really have a linear order anymore, right? So you then have the circular order. So you might have, so let's say this is 1, 2, 3, 4, and 5. So it might have started like this, 1, 2, 3, 4, 5, and then slowly it might, 1 second. Yeah, so slowly it might become something like this. So one might be still here, two might have moved on, three and four might be here, and five might have come behind one, right? So they will not overtake each other. They will always be in the same relative circular order. So their circular order is still maintained. So they'll still be in the correct circular order. But after that, they then come back and stand in the ground. And let's say now their order is like this. So it's 4, 5, 1, 2, 3. So the circular order is still maintained, but now it's not in the sorted order linearly. So yeah, yeah. So now the issue is the student might have gone missing. So you basically know the heights of all the students, and you know the height of the student you are trying to find. So you basically have to find if student you are trying to find is present in this list of students or not. So this basically boils down to finding if a number exists in a list of numbers where the numbers were in a sorted order and then they have been rotated, right? So this movement is called rotation. So if you have like the number 1, 2, 3, 4, 5, or any sorted array, so they don't need to be contiguous. So any sorted array, and then if you take the last element and put it at the left of the first element. So this is one rotation. Similarly, if we do it again and we take the last element, move it to the left of the first element, we get two rotations, right? So this is the example that we were talking. So if we have a rotated list of sorted numbers, we need to find whether a number exists in that list. So one obvious solution is obviously to brute force. So you can check each number. So let's say I want to find x equals 2. So I can check if this is 2, so it's not 2. So then I check the next one, is this 2? This is also not 2. Then I check the next one, this is 2, no. And then I check this one, and yes, this is 2. Right? So I can either check in a linear search, but however, we can see that the list was sorted, right? So although it is not sorted currently, so we cannot directly apply a normal binary search in this. However, it was sorted and it is still in a correct circular order. So in this case, we can still perform a modified version of binary search. So to do this, 1 second. Yeah. Yeah, to do this, we'll see how the code works. So first of all, let me just clarify again the inputs. So the first line of input is a single integer t, which is the number of test cases. So we will do the same search thing for multiple times in one input itself. Humayun, you can mute yourself. Yeah. So each test case will have two lines, right? So what this means is if there are three test cases, the first line will say 3, and then there will be 6 lines, right? So for each test case, there will be 2 lines. Then the first line of each test case contains two integers n and x, denoting number of students and the height of the target student, right? So the student we're trying to find. And then finally, the second line is a list. It is a sequence of integers, a sequence of n integers to be specific, and they are space separated. Right? So it will be present just one after the other with a single space between them. And then we again have a few constraints. So the t is 10 to the 3, n is 10 to the 3, x and ai, which is like the target student's height and all other students' height, is between 10 to the 15. So again, this is something that integer in C, C++, and Java cannot handle. So you should be using long in this case to handle for this. right? And finally, we are saying that AI equals AJ implies I equals J. So what does this mean? This simply means that all elements are distinct, right? So if two elements have the same value, it means that their index are the same. So in no other ways is it possible that two elements will have same value. So all elements are distinct. So let us see the, 1 second, maybe zoom out. So let us see the, it's not working. Just give me 1 second. Let me figure this out. Yeah. Okay. So for each test case, we have to print the index of the target student for the, like, if it's present, and if it's not present, then we print -1. So for example, in this question, if let's see the example. So in this question, if we have seven number students and we want to find zero, so here we have found zero here. So our output is 4. However, if in the same we are trying to find 3, then we don't have 3 here. So our output is -1. Right? So basically, it's a simple searching question. But instead of doing brute force linear search, we have to actually do a binary search here. So let's see the solution. So we'll go through the Python solution. All the other solution also are the same, but in different languages. Right? So this is similar to binary search if you have worked with binary search. So let me zoom this. Yeah. So first we will start with two variables, left and right. So we will, because we have the entire array, let's say this is 4, 5, 1, 2, 3, and we are trying to find 2. So we'll start with left and right. Left will be the leftmost element, right will be the rightmost element, similar to binary search. And we will iterate till the left pointer is to the left or equal to the right pointer. And then in each, we again calculate the mid, right? So the mid is the middle element of these two. So left plus right by 2. So here we are in the index 0. This is index 1, index 2, index 3, and index 4. Right? So 0 plus 4 is 4. 4 by 2 is 2. So mid is 2. So this is where our mid is right now. And then we will check if the mid is equal to the target. So if we directly find, then very good, we can just report it and we can return. However, this is not true, right? So we cannot return this. So instead, if now we will check if it's lesser than or greater than. So if the nums at left, which is this one, 4, if this is lesser than the nums at mid. So is 4 lesser than 1? No, right? So this is what it should have been if it was a sorted array. But because it's a rotated sorted array, this is not true. So 4 is not lesser than 1. So this is not true. So then we go to this else. So here we check if nums of mid, which is this one, is lesser than target. So yes, 1 is lesser than 2, which is true. And also target is lesser than nums of right. So nums of right is 3. So, and 2 is lesser than or equal to 3. So this condition is true. So what this means is this part of the array is still sorted, right? So in a rotated sorted array, we will always have two segments which are sorted. So wherever the rotation happened, two segments which are sorted. So this part will be sorted and this part will be sorted. But when we compare something in between these, it will obviously not be sorted. So what this means, so if this is true, this means that this right side of the mid is sorted and our element also lies in the right side. So then we can simply discard the entire left side because we know that our element is not on the left side. So then we set left equals mid plus 1. So now our mid has changed and our left has changed.
तू कितले चिकट होणार 125
Aditi, you can mute yourself if you're not. Okay. Yes. Okay. So then we'll basically iterate again, right? So we keep on doing this. So now we have left is again still lesser than or equal to right. So 3 is less than equal to 4. So we continue and then we get mid. So 3 plus 4 is 7. 7 by 2. So 7 integer division or float division by 2 gives us 3. So we have 3. So the mid is also. So this is also the lower. This is also the mid. So now mid is 2, and now we have directly found the element, right? So if the num mids equals target, we return mid. So we can directly return the index 3. So I'll just explain how this part of the logic also works, even though we did not encounter it in this example. So this basically says is if I've not found the element, but the nums at the left, so this num, the number at the current left pointer, is less than the nums in the mid. So the if the left part of the array is sorted, right? So here the left part was not sorted, but if the left part of the array is sorted, so let's say we have a few numbers which is not sorted, 5, 4, or let's say not just 5, let's get some bigger numbers. So let's say we start at like 7 and 8, and then we have things like 1, 2, 3, 4, 5, 6. So if after a few things like we have discarded these parts, but now if let's say our left is here, our right is here, our mid is here. So now the left part of the mid is fully sorted. So if that is the case, then we will check if the mid is in between the, so if the target is between the mid and the left. Right? So if let's say this was our target, then it is between the left and the mid, then we can discard the right. Right? So we can take the right pointer and move it here. So that is what we're doing. Right equals mid minus 1. And if it is not, then so if it is on the right side of the mid, then we can take the left and set it to be mid plus 1. So we can move the left to the right side. So very similar to how binary search works. We just have to have an extra check seeing whether the side that we're comparing is actually sorted or not. Right, so let me clear this. Okay, so that is basically the thing. And similarly for the other side, if it is, so if it's this one left equals mid plus 1, otherwise right equals mid minus 1. So same logic as the previous loop. And then finally we take the input. So this here is just the driver code. So we take the input, t equals into input. We take how many test cases there are. We iterate that many times so dunder is just an unnamed variable in Python. For dunder in, sorry, not dunder, for a single underscore. In range t, we iterate t times and then we get both the numbers n and x. So we take our input, like one line of input, we split it by space. So we get two different strings. We get the string of the n and string of the x. But instead of string, we want them as integers. So we map them to be integers. And then finally, we also take the array as the input, which is the second line. So again, we take input, we split by these spaces, we map them into integers, and we convert them into a list. Right? So we're just taking input at this point. And then finally, we call the function search with the ARR array and the element to search. So that is the Python solution. Similarly, we have solution for C++, C, and Java. So you can also go through the other solutions. So here everything remains same. You just have to make sure that you are using long wherever you're storing the numbers because we need to actually cannot fit in it. So you should have long x here, and the vector itself also should be a vector. It's clear this. Just let me know if you have any doubts in this question. Otherwise, we can answer that. So we'll move on to week 2, question 2. So Pulkit, you can take over. Hello. Yeah, sure. So in the meantime, does anyone have any other doubts? week 1 programming assignment 1, week 1 programming assignment 2, week 2 programming assignment 1. Or if you have any other doubts, you can let us know. We might not be able to discuss them in this session in depth, but yeah, in the next session, Atul sir will also be there. So we'll discuss the theoretical questions also, or the graded assignment questions also. In the meantime, if you have access to the discussion forum, you can drop your queries in the discussion forum also. Like you don't have to wait for the live sessions. You can drop them in the discussion forums and we'll take a look at them.
Hello.
Yeah, you're audible.
Yeah, thanks. Okay, so let me share my screen first. So this is the programming assignment question 2 for the week 2. And the question says, during the pandemic era of 2020, Chennai faced a severe outbreak of COVID-19. A citywide lockdown was imposed, restricting people from leaving their homes. To ensure citizens had access to essential supplies like food and medicine, the state government of Chennai devised a plan to use drone for contactless delivery, maintaining a strict social distancing protocols. Each drone has a fixed carrying capacity represented as an integer in the array capacities. So we have a array capacities which basically represents how much a drone can carry some weight. And all drones are identical in functionality apart from their carrying capacity. So the speed of movement all are same for all the drones. The only thing that differs from one drone to another is how much each drone can carry on the weight. To optimize the delivery process and minimize resources wastage, the government aims to select exactly X drones such that each of these X drones has a carrying capacity of at least X. This selection ensures the fleet's efficiency aligns with the demand for heavier deliveries. Your task is to determine critical capacity X such that exactly X drones that can meet the criteria. If no X exists, then we return -1. It is guaranteed that if a carrying capacity exists, it will be unique. Now let's move on to the input format and then we will explain what's the logic behind to solve this question. The first line of the input contains a single integer t, which represents the number of test cases. For each test case, the input consists of two lines. The first line contains a single integer n, which represents the length of the array, and the second line contains n space separated positive integers, representing the array capacities. Then our constraint are that the t would be less than 10 to the power 5, and the n basically the number of drones in the capacity would be less than equal to 10 power 5. And the carrying capacity of a drone would be less than equal to 10 to the power 15. And the output is return the integer x if the carrying capacity exists, otherwise -1. So let's take an example to understand what the question wants to say. So we have a 3 test case here. For the first test case, there are 2 drones with carrying capacity 3 and 5. Now how the solution is working that if we let's start from the 0, then there must be 0 drones having carrying capacity greater than equal to 0. But there are exactly 2 drones which have carrying capacity greater than 0. So 0 will not be the answer for this. And in fact, 0 will not be the answer for any of the case because it is mentioned that our carrying capacity are positive integers. So 0 will not be the answer for any of the case. Now let's start with 1. There should be one drone which has a carrying capacity of greater than or equal to 1. But the carrying capacity of both the drones are 3 and 5, which are greater than 1. So there are two drones which have a carrying capacity of greater than or equal to 1. So 1 will not be the answer. Now let's move on to the 2. So there should be exactly two drones having carrying capacity greater than or equal to 2. And that is true because we have two drones here exactly which have a carrying capacity of greater than or equal to 2. For the second test case, we have 5 drones and these are the carrying capacity of each of the drone. Now let's again start with 0. So as I mentioned, 0 will not be the answer for any of the case. If we let's check for 1, there should be exactly one drone having carrying capacity of greater than or equal to 1. But we have 5 drones which have a carrying capacity of greater than or equal to 1. Now let's move on to the 2. Then for x equal to 2, there should be 2 drones capable of carrying at least 2. But there are at least 4 here. So the 2 will not be the answer for this. Now let's move on to the 3. There should be 3 drones having carrying capacity of greater than equal to 3. But these two are the drones which have a carrying capacity of greater than or equal to 3. 3 is not the answer. Let's check for 4. There should be 4 drones which have a carrying capacity of greater than or equal to 4. But again, these two drones, 5 and which has a carrying capacity of 5 and carrying capacity of 6. These two are the drones which have a carrying capacity of greater than equal to 4. So there are 2 drones, not the 4. So 4 will not be the answer. And if we check for 5, there should be 5 drones which have a carrying capacity of greater than or equal to 5. But there are again 2 drones which have a carrying capacity of greater than or equal to 5. Now we can at max run for the n times for this loop because we have only n drones. So we have to check whether uh, the final loop that we will run is still n, that there are n drones which have a carrying capacity of greater than or equal to n or not. Now if we move on to the solution part, first we are taking the number of test cases for the input. Then we are running this loop t times. And for each test case, the first line was the number of elements in the carrying capacity array. So we are taking that as an input. Then the next line was there would be n space separated positive integers. So we are taking them as an input and using split, we are creating the list of that. And using the map function, we are converting each element of the list to the integer because the input, when you take the input, each element would be as the form of string. So we are converting them as integer and storing them as a list. And we are declaring that as a capacity. Next thing is we are doing is the sort. So we are sorting it in the reverse order, that is in the decreasing order. So we are sorting all the elements in the array capacity in decreasing order. And then we have set a carrying capacity to be false. Now we are checking if the last element of the capacity array is greater than equal to the length of the capacity. So last element of this capacity, because we have sorted it here, the last element would be the smallest element in the capacity array. So if the last element itself is greater than the number of elements in the capacity array, then all other elements would also be the greater than or equal to this n. So that means this would satisfy our condition for critical capacity. And then the answer for that x, that is the carrying capacity, would be just the length of x, because there would be n such elements in the x which would be greater than equal to n, because the smallest one itself is greater than equal to the length of the capacity. So all the remaining elements would also be the greater than equal to. So as we have found the critical capacity, we have set our variable to be true. If this condition is not satisfied, that is the smallest element is not greater than equal to the length of the capacity, then we are running a for loop from 1 till the length of the capacity. And we are checking if I minus 1 element of the list is greater than equal to the I, and the ith element is less than I. If that case happens, then we are printing the I and we are setting the critical capacity to be true, and we will break through this loop. And if both of the above case don't happen, that is just if condition and in the for loop, then the critical capacity would have the value false. And in that case, we'll print -1 because we have not found the critical capacity. Now, if you more want to understand how this logic inside the for loop is working, then suppose we have this reverse sorted array 5432. Then we are checking if the I minus 1 element. So as we have started with range from 1, the I minus 1, that is this 0 element here, if this is greater than equal to I, that is this 5 is greater than equal to 1, and the capacity I, that is the element that is at the 1 place, that is this 4, if this is less than n. So I minus 1 element should be greater than equal to I, but the ith element should be less than I. If that scenario happen, then we will print that I. Because if we run this for loop, then we will encounter that many elements which should be greater than equal to I. And that is what we have to find out. And if that case happens, then we are setting printing the I and setting the critical capacity found to be true. If that does not happen, then the critical capacity would always be false, and we will just simply print -1. So that's what we are doing here, and the same type of solution is there for rest of the language also. Here in the C++, we have to create one function to sort that array, and we have to just set the capacity element with the long, because there might be elements which are uh, quite greater. And same thing is there in the C. Here also we have to make sure that we set the elements in the array capacity with the long. And this is the code for Java also. You can go through it later. So anybody has any doubt? Okay.
All right, I guess that's all the questions for week 1 and week 2. So let us know if you have any other doubts. Right? So usually these sessions where we discuss the programming assignments, this will be pretty short and crisp like this. So we'll just go through the question, we'll discuss the question, the way of, and then the solution and a few pitfalls that you should keep in mind. And if you have any doubts for those questions, you can also voice them during these sessions. You might also have theoretical sessions. I'm not sure if they're scheduled yet, where I will take your like general questions about the subject, about the weekly assignments, etc. Right, so yeah, that's all for today's session. If you have no other doubts, then I think we can wrap up. Oh, yeah. If no other doubts, then we'll end for today. Thank you all for joining. You can end the meeting now.
Good night, everyone.